For the next example, we're asked to integrate 4t cubed minus t squared plus 16t over t squared plus 4 dt. Whenever you're given a fraction like this, a lot of times I say try to factor. In this case, if you try to factor, you're not going to get very far. Another great idea, especially when the degree of the numerator is larger than the degree in the denominator, is to go for some long division. So that's what I'm going to do. I'm going to divide. So I'm going to take that denominator of t squared plus 4 and divide it into our numerator. So when we divide t squared into 4t cubed, I need to multiply by 4t. So 4t times t squared is 4t cubed. 4t times 4 is 16t. Now we're going to subtract, so we change both those signs, and everything here cancels out. So I'm left with negative t squared plus 0. So t squared into negative t squared, need to multiply by negative 1. So we have negative t squared minus 4. Again, when I subtract, change of signs. So I'm left with a 4. So we have plus 4 over t squared plus 4. So I'm going to rewrite this. So we're going to integrate 4t minus 1 plus 4 over t squared plus 4 dt. And by the way, this is a personal preference thing. If you wanted to write this as 3 separate integrals, you could do that. So if you wanted to, you could write 4 times the integral of t dt minus 1 dt and 4 times the integral of 1 over t squared plus 4 dt. I mean, you're going to get the same answer either way, but if you want to break it up as 3 separate integrals, that's totally fine. The first 2 are very straightforward, pretty easy to integrate. The third one actually uses one of the formulas. Not going to go back to the table, but I will just give it to you. Number 19 from that table says that if you're asked to integrate, and it has x's on the table, so I'll just go ahead and do the x's. Dx over a squared plus x squared, that equals 1 over a times the inverse tangent of x over a. So let me just kind of separate this off. So it's like a little side note here. That's what we're going to use here for this third one. Obviously, we have a t instead of an x, but otherwise it's very straightforward application of this. And in our case, the a is going to be 2, 2 squared being 4. So let's go ahead and integrate. We've got 4 times t squared over 2 for the first one, minus t in the middle. Then we have 4 on the outside. Using this formula, I've got 1/2 times the inverse tangent of x, not x, but 2 over 2 plus c. So if I clean this up just a little bit, getting rid of the denominators, I'm left with 2t squared minus t plus 2, times the inverse tangent of t over 2 plus c.